Okay, let's look at how we can theoretically determine the metacentric height. So this is the formula for that. So if let's look at the figure first. So imagine that the pontoon plan is like this one. So we have like the length of the L and the width of the B, okay, and this pontoon uh, tilt will take place about the x or longitudinal axis. So this is like the key question that we can discuss it later. Why this kind of like the tilting is more critical than tilting about the latitude, like the axis. So and why it's not like the tilting is not happening on the like the other like the axis, and it's just going to just be on the longitudinal axis. Anyway, having had like these assumptions that the critical axis is like the xx, so the question and the thing here is that we just have like if you just look at it from the side view of the pontoon, we can see, for example, we have a depth of immersion like the h. We learn from this chapter that the h can be calculated by division of the volume water displaced divided by the lb, okay, and the center of the pressure or the buoyancy acts as point B, which is the center of the displaced water, which is the half of the h. So it's like the h seconds or h over 2, you can see here. And imagine the center of the gravity, G, is located somewhere in here, okay? And we know that like for example, the point M is like for example, metacenter is like the point M. And the question here is to calculate the BM or the GM. So we are going to calculate the GM. We prove it later that the BM for this pontoon, or the general term like the pontoon, is calculated by using this formula, which is the second moment of the area, IWS, the second moment of the area, which is about the longitudinal axis, which is equal to the L, or the length, times the B cubed over 12. So second moment of the area can be calculated by this formula, L, because like if I'm just going to show you here, for example, this is going to be tilting in this direction, and the second moment of the area is about like this kind of like the axis, which is equal to the L times the height, or the B cubed over 12. So we have that formula, and the BM is like the second moment of the area of this around like the x axis divided by the volume of the water displaced, which is the V in here in this case. Okay, and if you have like the BM in this formula, the point here, as we learn, is for the stability of the pontoon is to calculate the GM. So the GM can be written by using this formula. GM is equal to the BM minus BG. BM is calculated by using this formula that we explain how it is, what terms it has. And the BG, to calculate the BG, we need to just know the point B. We know the point B from the base, which is like the h second, or the half of the depth of immersion, okay? And point G is the center of the gravity that can be easily calculated by taking the moment about point O, for example. If this is like the, for example, a regular shape, for example, it can just be easily calculated by taking the intersection of the diagonals, or for any kind of like the regular shapes, we know where the center of the gravity is located, and by taking the moment about the base, for example, we can just calculate the location of point G. And the OG here is calculated. Once we're just going to have that one, easily, if you take it away from the OB, you can easily calculate the BG. And once you have the BG, take the difference of the BM and BG, BM minus BG, BM minus BG, it's just going to be equal to the GM, which is the point that we're just going to calculate. Let's look at one example here. and see how it works. We have a loaded pontoon as a mass of like 200,000 kilograms or 200 tons, has got a length of 20 meters, width 9 meters, and its overall center of the gravity is 5.6 meters above the base of the pontoon. And the pontoon floats in salt water with a density of 1025 kilograms per cubic meter. So the question here is that, is it stable or not? Let's just use this formula or this figure bear in mind. So we need to calculate, first of all, like the BM and the GM based on the formula that we learned. So first of all, to calculate the water of the volume displaced, we need to just use the original formula of the buoyancy, or the volume of the water displaced is equal to V equal to the mass divided by the density. Mass like 200,000 divided by 1025. The volume of water displaced is 195.12 cubic meters. And the depth of immersion is like that volume divided by the length times width, so B, divided by 20 times 9. 20 times 9 is given for us length and width. And the depth of immersion is equal to 1.08 meters. Okay, once we're just going to have that one, the half of that, or point B, can be easily calculated as a half second, which is equal to 0.54 meters. So once we're just going to have like this one, on the other hand, we can easily calculate the BM in the formula, if you remember, the second moment of the area divided by the volume, and the second moment of the area is like the LB cubed over 12. So the BM can be calculated by B is like the 20 meters, L is like the 9 meters cubed raised to the power 3 divided by 12. So that is like a calculated here. The 12 is calculated in this case. Okay, you can see here the BM is the I, which is like the LB cubed over 12, so which is like a 20 times 9 cubed over 12. And the BM, we have another term like the volume of the water displaced. So it will be in the denominator of this fraction, which is 195.12 cubic meters. We're just going to put it here. And the result of this calculation, BM is equal to 6.23 meters. So once you're just going to have like a BM is calculated here, we need to just have we know the like, for example, the center of the gravity is like a 5.6 meters. OG is given to us. So the BM is calculated. If you just if you're just gonna have the OB as well, we can have the OM, and if you're taking away from the OG, we can have the GM. So by adding the BM, which is a 6.23, plus the OB, which is a 0.54, we're just gonna have like the OM, or the height of the M above the base, which is equal to 6.77 meters. So 6.77 meters minus the OG, which is the center of the gravity, minus the 5.6 will give us the GM. So OM minus the OG, which is 6.77 minus 5.6, is equal to 1.17 meters. So we're just gonna say the GM is like the positive value and large enough, so this pontoon, it will be definitely stable. Or on the other hand, you can say like the M is above G. As long as M is above G, obviously the GM is positive. And you say like the 6.77 is greater than like the 5.6 meters. So obviously like the GM exists as like a positive value, and it's equal to 1.17. And we say this is like the stable.